Hello everyone. Today we begin the course Battery Management System. Course code is 25EVT211. This course mainly focuses on understanding how a battery management system ensures safety, reliability, and optimal performance of battery packs, especially in electric vehicles. By the end of this course, you will be able to understand battery fundamentals, how you are going to measure the battery parameters, and how you are going to estimate the state of charge and state of health. And also, you will see how to analyze the fault detection mechanism in the battery systems. Let's continue to the unit 1. Let us first understand the major components of battery management system. Here, typical battery management system consists of power module, battery, DC-DC converter, load, communication channel, and some examples and their comparison. Okay, first, the first component is the power module. Okay, where this power module controls energy flow between the battery and the load. And second one is the battery pack. This battery consists of series and parallel combination of cells to achieve the required voltage and capacity. Okay, now coming to DC-DC converter, this is the third component where it regulates voltage levels and provide the required power to the auxiliary systems. Next is the load. In electric vehicles, we know that the load is the motor, that is a traction motor and associated electronics. Fine. Then coming to this communication channel, the BMS has to communicate with the vehicle. That is nothing but VCU. We know that vehicle control unit. Okay, to transmit the data such as voltage, current, temperature, and fault information. Okay, now coming to this comparison, we are going to compare low end and high end devices, where in low end devices like electric shaver, the BMS is very simple. The BMS is very simple, where it mainly prevents overcharging and deep discharge, OC and DD. So low end systems where the BMS is very simple, where it's only control OC and DD. Okay, in high end systems like electric vehicles, the BMS will perform the complex tasks, okay, including cell balancing, SOC estimation, SOH prediction, and advanced fault diagnostics. Thus, the BMS complexity depends on the application requirements. So, whenever we are designing the BMS, we need to see for which application we are designing it. Now, coming to the second part of Unit 1, basic information. Okay, where now let us understand the basic concepts of BMS. A battery is an electrochemical energy storage device that converts chemical energy into electrical energy. Okay, now we need to understand the important battery parameters, which includes voltage, capacity, and energy density, as well as the internal resistance. Okay, these four parameters we need to understand first in the basics of battery. Okay, where battery voltage is determined by the thermodynamics potential, and it is affected by over potentials such as kinetic and diffusion over potential. We are going to see in detail when we are discussing about the battery voltage parameter. Now, the double layer capacitance also exists at the electrode electrolyte interface, and which will affect the transient behavior of the overall battery. Now, understanding these parameters is essential for designing an effective BMS. Okay, and coming to the third part, here you can see lithium ion batteries. Okay, now lithium ion batteries are widely used in electric vehicles due to the high energy density, and long cycle life. Okay, now this lithium ion cell consists of a cathode, anode, electrolyte, separator, current collectors. Okay, we will see the basic operation and construction and what under the chemistry we are going to use in lithium ion cell. Okay, then during and charging and discharging, lithium ions will move between cathode and anode through the electrolyte, where the safety is extremely important in lithium ion batteries, as improper operation can lead to the thermal runaway. Okay, improper operation can lead to thermal runaway. Fine. Therefore, integration of lithium ion battery with BMS is very critical. We are going to see battery management system components, basic information on the battery, and lithium ion battery fundamentals in unit 1. And coming to unit 2, here where major focus is on BMS control, measurement and control. Okay, we focus on practical BMS implementation in unit 2. The first important function is measurement of battery parameters, where cell voltage measurement is essential to detect the imbalance and over voltage condition. Over voltage condition. Okay, as well, the current measurement can be done using the shunt resistor or Hall effect sensors. Okay, now synchronization of this current and voltage measurements is important for our accurate SOC estimation. Okay, now this temperature measurement is equally critical because battery performance and safety are highly temperature dependent. As we all know, the battery has to work in different environments. We need to take care of that while designing the BMS. Now, measurement uncertainty directly affect the performance of SOC and SOH estimation algorithms. Okay, now coming to battery functionality. Okay, the most common method is constant current and constant voltage method. Also, we are going to call it as CC and CV charging. In this constant current phase, the battery is charged with the fixed current. Battery is charged with fixed current until it reaches target voltage. And coming to CV, the voltage is maintained constant while current gradually decreases. And thermal management ensures battery operates within the safe temperature limits. So, operational modes also include this charging and discharging modes, idle mode, and protection mode that we're going to see in this system functionality. Then coming to this charging or charge balancing, okay, in multi-cell battery packs, cells may not have identical capacities. Okay, over the time, imbalance between the cell occurs. So, charge balance ensures equal voltage, and charge distribution across all the cells. Okay, now here there are two main methods. First one is passive balancing, passive method. Second one is active method. Where in the passive balancing, excess energy is dissipated as a heat. We need an external circuit in the passive balancing. Where in active, energy is transferred. Okay, if I'm going to take three different cells, energy is transferred from higher charge cell to the lower charge cell using capacitor, inductors, or transformers. Okay, now comparing to passive and active, active balancing improves efficiency but increases system complexity. Increases system complexity. Okay, now coming to this state of charge estimation algorithm, here we know that SOC which indicates the remaining charge in the battery as a percentage SOC. Okay, one common method we are going to use as Coulomb counting, where current is integrated over the time. Current is integrated over the time. Okay, current is integrated over the time. However, due to the integration, error will accumulate due to the sensor inaccuracies. Okay, now in SOC estimation, Coulomb counting, then another method is open circuit voltage method. Open circuit method, that is OCV method, which relates the SOC to the voltage. Now we are going to use advanced methods such as Kalman filtering, which use battery models to improve the accuracy, as well as we are using observer method techniques, okay, where real-time estimation can be done. Fine. Then coming to the unit 3, where this unit 3 is for SOC estimation and fault detection. Okay, now here SOH represents the condition of the battery compared to the new battery. Where battery degradation occurs due to the capacity fade and increase in the internal resistance. Okay, so these SOH estimation algorithms can performed using 4 different methods: impedance detection, capacity estimation method, self discharge analysis, and predictive models. Okay, where we can know the remaining life of the battery. And first we are going to know the health of the battery, then we are going to know the remaining useful life of the battery, that is RUL, where this estimation predicts how long the battery can operate before the replacement. Okay, that we are going to see in this SOH estimation algorithm. Then coming to fault detection algorithm, we can see here we have listed different fault scenarios, okay, which includes overcharge, over voltage, over temperature, over current conditions, internal short circuit, lithium plating, excessive capacity loss. Okay, where the BMS, what we are going to design, must detect these conditions early and which need to be initiate the reaction strategy such as disconnecting the battery, reducing the current, or triggering the alarms. Now, effective fault detection methods can prevent the failure before it occurs. Okay, now this battery management system is the brain of the battery pack. Okay, it ensures safety, optimizes the performance, extends the battery life, and enables reliable operation of the electric vehicles. Here you can see in Unit 1, Unit 2, Unit 3, we have covered requirement of BMS, overall requirement of the BMS, where 16 hours, 17 hours, and 12 hours, total 45 hours. The course syllabus is framed to cover overall BMS requirement, where in the upcoming lectures, we'll study each topic in greater details with mathematical model and practical examples. Thank you.